So good morning or good afternoon or good evening, Math 9 students. So today we're going to do 5.2. So let's have a look at that. You should have this handout already. And so lesson 2 is on what we call equivalent expressions. So first of all, we want to go through and we want to have a quick review here of what a coefficient is. Now we talked about coefficients in chapter 4. So you might want to write this down again. So what is a coefficient? A number that multiplies the variable. So, for example, in the expression 3n minus 4, the variable is n. The number that is in the front there, multiplying it, is 3. So the coefficient is 3. All right, so we dealt with that in chapter 4. Now the next thing here is we've got what are like terms. Well, we'll put up a definition here and then we'll go through and we'll discuss it. So, terms that have the same variable or variables raised to the same exponent. So let's think about a few examples that we could have here. So if we had 4x, the coefficient of course is 4, the x is the variable. If I had negative 3x, what do you notice? What's common about those two? What's common here is that both of them share the same variable x. So they're said to be like terms. Now, I think probably the best thing we can do is we'll go through and look at the first example here and identify our coefficient, the variable or variables, and the exponents on the variable. And then we can talk more about like terms later. So, checking this out. So, the first expression we've got here is 3w, or 3 times w. So, did you think the coefficient is going to be 3? The variable, there's only one variable, and that is a w. Now let's think about the exponent that goes with the variable. Well, I don't see an exponent, do you? Well, if there's no exponent there, we're going to take that as just being a 1. So the exponent here is just w to the power 1, which we normally don't write in. Okay, let's look at the next one here. So we've got a squared. What's the coefficient going to be? I don't see a number in front of the variable, so if there's no number in front of the variable, we take that as being a coefficient which is effectively 1, isn't it? So it's like 1 times a squared. So the coefficient is 1, the variable is a, and the, don't know what that was all about, the exponent that goes with the variable is 2, because it's a to the power of 2, or a squared. Right. Let's do the remaining two quickly here. So for this one, for C, negative 4xy, coefficient is negative 4. The two variables that we got here are both x and y. And what's the exponent that goes with both of those variables? Well, it's x to the power 1 and y to the power 1. So in both cases, the variables have an exponent of 1. Right, what about the last one here? We've got a minus g. All right, so first up, g is the variable, isn't it? And the exponent on the variable is a 1. Let's talk about the coefficient here. So the coefficient, don't see a number again, but we've got a negative sign. So that's like having negative 1 times g. So in actual fact here, the coefficient is negative 1. All right. Going on, identifying like terms. So up the top here we had a definition of what like terms were. Terms that have the same variables raised to the same exponent. So looking down here, we've got several terms that are listed here. So let's go through and have a look. Well, first of all, let's take the first term that we've got there. The first term we've got is 5b squared. So running through the other terms here, do we see any other term that's got the same variable? So some of them have got a b, but no b squared. So this one here is all on its lonesome. There's no other like term with 5b squared. Right, let's have a look at 3cb. All right, two variables, which are C and B. There's none of the other three remaining terms have the same variables, do they? So that one there, it's on its own as well. Then we've got the next one, which is minus 2b, and we see over here we've got a 6b. We've got the same variable. So minus 2b and 6b, because they have the same variable then and the same exponent with each variable, they're going to be called like terms. All right, let's go through and have a look at the next one here. So let's have a look at B. So B, let's check out the let's check out these terms. We've got 5 terms here. Now our first term here is 3x squared. So our variable is x squared. So if we run along here, all right, we've got this term here also has the variable x squared. Exponent is 2 and the variable is x. And then we've also got this one here, 7x squared. So these 3 terms that I've circled here, they're going to be like terms. Looking at the remaining 2 terms, the 4xy and the half y, well, they're not the same. They don't have the same variables, so they're going to simply be on them by themselves. So we've got 3x squared, we've got negative 2x squared, and we've got 7x squared. And once again, they're similar on account of them having the same variable and the same exponent with each variable. Let's proceed over to the next page there. So, looking at C here. So, checking this out, our first one here is we've got 3pq, the variable is pq. Now, if we run along the remaining terms, we've got the last one here is a single pq, same variable. So, these 2 here are going to be like terms. Looking at the remaining ones there, we've got, what's this? This is 11, which is, hey, we call that a constant term, don't we? And we've got minus 3 there. So the 2 constant terms, they don't have a variable, but we would treat them as being similar terms, even though they're just simply numbers. And then lastly, we've got q squared, and that's just by itself, so that doesn't pair up with anything. So we can say here, our like terms are going to be, we've got the 3pq and the pq, and I'll change colors there, and we can treat the constant 11 and the minus 3 as being similar terms as well. So what we want to do now, this is when we start to do some real algebra, is we're going to look at going through and combining. We're going to be given an expression and we want to combine the terms that are like. Now we're going to do it a couple of different ways. We're going to use algebra tiles, and then we're going to think of it using symbols as well. So let's do A, and we're going to be using, now remember how we use our algebra tiles? So quickly from from the last exercise that we did, from 5.1, we had, remember we had our special tiles. So let's just quickly go through and recap then. The big green tile represents an x squared. The clear tiles, the ones that are white, represent the opposite, which is negative x squared. The rectangular green one is an x, and then a minus x, and we've got a plus 1, and we've got a minus 1 there. So let's have a look at what we've got first of all. We've got 4x minus 2x. So I'm going to go through. We've got 4 x's, so this is going to take a moment to do. And you can sketch them on your page as well. Then we've got minus 2 x's. Then we've got plus 3. So we've got 3 unit tiles. A little hard to drag. And then we've got minus 6. Now, what's going to happen here? So the green ones represent a plus x, and the white ones represent a minus x. So a plus x and a minus x, of course, gives us 0. Similarly for the one next door here, plus x and a minus x is 0. So what are we left with? We're left with 2 green ones, which is 2 x's. Plus 1, minus 1 with our units. So these all become zeros, and we're left with 3 white ones, which is going to be minus 3. Now, we could have done that without using algebra tiles by thinking about it algebraically. So we look at our terms here, we've got a 4x and a 2x. Now, those are both like terms, aren't they? Because they have the same variable. We've got 4 x's, and we can take away 2 x's. 4 minus 2 is going to leave us with 2 x's, isn't it? And then we've got the 3 and the minus 6. They are both constant terms, so they're like terms. 3 minus 6 is going to be minus 3. So that's thinking about it algebraically and thinking about it with a model. Right, let's go through, and if you can start off with B here, I'm going to, first of all, we've got 2x squared. So those are both similar terms. We've got a 1x squared here. So I'm going to drag these ones down. We've got 2x squareds. And then I've got another one along there, which is a 1x squared. Then we've got, changing my colors here, we've got a 3x there and a minus 4x there. So 3 x's. And my minus 4 x's are going to go underneath, because I'm going to keep my negative ones underneath. And then lastly, we've got 2 constant terms. So we've got a minus 1 and we've got a minus 2. So there's my minus 1, and then we've got a minus 2. So look at that. Now, what are we going to be left with here? So we've got 3 of these tiles here, so that will give us a 3x squared. With our x and our minus x terms, a plus x and a minus x gives us 0. Same with that one. Same with that one there. And we're left with 1 minus x term. So that's going to give us minus x there like that. And then finally, we've got 3 units there which are negative, so minus 3. So there's our simplified expression. 3x squared minus x minus 3. Now, doing it algebraically, same sort of process. We go through and I've got a 2x squared there and I've got a 1x squared there. So I'm going to check off all my like terms first of all. I've got a 3x and a minus 4x there. And then lastly, we've got a minus 1 and a minus 2. So the 2x squared and the 1x squared, these two here become 2 plus 1 is our 3x squared. The 3x minus the 4x, 3 minus 4 gives us a minus 1x, or simply minus x. And then we've got minus 1 and minus 2, which gives us minus 3. Right, why don't you go through and have a look at C, and I'm going to pause the tape here while you take a few minutes to go through and do that one. So you should have got a picture something like this. So we've got, checking this out, we've got 3x squareds there. Those are all x squareds. the minus x squared is this one here. We've got two positive x's, and then underneath we've got minus x's. Then we have the plus 4 there, and we have the minus 5 here. So going through, x squared minus x squared, that pair becomes a 0, doesn't it? The x minus x, both of these give us 0 pairs. So we've got end up with no x's. And then we've got each of these pairs, 4 of them become zeros, and we're left with a single minus 1 there. So at the end of the day, what are we going to have? We're going to have 2x squared. The zeros all cancelled out and became 0 pairs, and we've got a single minus 1 there. So that's what that expression simplifies to. Now, once again, we can do that without having to go through and use algebra tiles. So we go through and we check off the terms that are the same. All right, so the x squared terms are like terms. We've got the 2x, I'm changing colors here, minus 2x, and then we've got our two constant terms, which are 4 and minus 5. So the 3x squared minus the 1x squared, okay, the coefficient is effectively 1, gives us the 2x squared. The 2x and the minus 2x, they add up to 0, so we've got no x's, so we just leave that blank. And then we've got the plus 4 and the minus 5. 4 minus 5 is going to be minus 1. Okay. Now, lastly, on the next page there, why don't you take a few moments to go through and, using whatever method you like, you can combine the terms here. I'll put up the answers, and if you pause the tape here, you can come back and check the answers. After that, all right, in class next day or sometime later, we're going to be working on these exercises from the book. So for A, did you recognize that the minus 3x squared and the minus x squared were the same type of term? Minus 3 minus 1 would be minus 4, and then the 5x and the 2x are both the same. Oops, we got a mistake there. Should have been the 3 minus 3x minus 1x squared, and then the 5x and the 2x. And that should have given you minus 4x squared, and the 5x and the 2x is 7x. Right, what about the next one here? We've got the 2x and the minus 2x are similar terms there, and the minus 6 and the plus 1 are both similar terms. So 2x and minus 2x is no x's, 0x. Minus 6 plus 1 should have given us minus 5. And then lastly, what do we notice? We have the minus k squared and the 5k squared are the same. 5 minus 1 is 4. 1k minus 3k minus 2k. And then finally the plus 3 and the minus 4 should have all given you 4k squared minus 2k minus 1. So that's the end of today's video, and next class we're going to be working on that. Thank you.